Cryptonumerics helps businesses to preserve the privacy of their customers, to meet compliance, while still allowing them to drive business growth from analytics. In this talk, I will discuss the different data types businesses are collecting, the risks they represent, and how it is possible to use all of this data to drive business growth and satisfy regulations. Let's discuss the various types of data that businesses have. In this example, this is their typical structured database of customers. We have different types of fields here: ID, name, as well as gender, age, marital status, education, zip code, and occupation. Now, there's a couple of very important terms on this slide: direct identifiers and indirect identifiers. So direct identifiers are fields that are unique to an individual, so ID and name in this case. Those other fields are called indirect identifiers. And indirect identifiers are still very important because if you combine those fields together, they can uniquely identify an individual. Take, for example, let's say in this audience, we have about half males, half females. So that's not very identifying. But now let's try and add in age. So how many 20-year-old males are in the room? Maybe there's 3. Now let's add in marital status. Let's say they're not married, 20-year-old male, and that might be one person in this room. We now just re-identify that individual. And what I mean by that is you can then take this data and connect it with another data set that has name and those same indirect identifiers, and you will know who that individual is. So this is all very important because anything that can re-identify an individual is considered personal data under the different privacy regulations like GDPR and CCPA, which is the California Consumer Protection Act, which is going to come into law in January of 2020. So data that is considered personal has a couple of things that are very important. You need to have, under GDPR, you need to have consent for each and every use of that data. Under CCPA, you must have informed your customer what you're going to do with that data and have given them the opportunity to opt out. If not, then you can't process it. Here's another example of some customer data. And this one is a little bit different in that it contains transactions. So consider credit card transactions. It could be banking transactions. Now, we have the typical direct identifiers, but now those transactions are also indirectly identifying. And why is that? Well, think about what's in those transactions. You have time and you have location. You have amounts as well, but those time and location could be combined with other information. Let's say Google Maps, or Find My iPhone, or any number of things that can identify where you are, when you were, and now people know what transactions you have had. The other thing that's in this is actually, if you look at line 4, Danielle Campbell apparently has made the same transaction every day at the same time in the same location. Well, that's a pattern. That pattern is also identifying. So you need to understand that all of those features in those transactions can actually lead to re-identification, which will put this data inside of scope for those different privacy regulations. Here's another different data type. This is unstructured or free text data. You can imagine this being a call center transcription. It could be client notes taken by a wealth management officer. It could be a number of different things that are sent into a text field. Doctor's notes is a good example. So in this case, there are also direct and indirect identifiers. Obviously, the names are direct, but now we have locations and dates. Those are indirect. So we need to take care of that type of information. And again, this will put it inside of scope. And the extra field here that we have is a sensitive attribute, which is merger. So the context could make this a very highly sensitive type of information that businesses hold on to. And the last one I wanted to show in terms of a different data type was an image. And we think of images, in this case I'm showing you an image of a couple of my colleagues at a conference event, so it's certainly not a private image, but there are a lot of stores, for example, retailers, that like to take pictures and videos of people in their stores so that they can optimize their store. They can also, you know, the layout as well as how they shelf things and how they present things to people. Those are all things that these retailers would like to be able to look at these photos. But these photos contain private information yet again. And so all of these different data types puts it in scope of privacy regulations. However, all of these data types present massive business growth opportunities. You can think of all the different use cases surrounding cross-selling, upselling, reduction of customer churn, improvement of customer experience and product offerings, store optimization, also even optimal store locations. In one scenario, you could look at, you know, where people were buying things and why did they go to that store versus this other store? What was at that store? So all of this information can really help businesses to grow and remain competitive. However, if that data is within scope and it hasn't gotten consent, or you haven't properly informed the customers of what you're going to do with that, you're stuck with privacy regulations. And within organizations, what we're seeing is the privacy regulations are shutting down access to the data. And on the other side, you have these business demands, which I just pointed out. So how do you deal? It's a struggle. And so on the privacy side, they're like, okay, let's mask it, tokenize it, and encrypt it. But the problem with that is your data scientist or your analytics team doesn't have any value left in the data. So what are you going to do? And this is where privacy automation comes in. Now, to take data out of scope for GDPR, you have to anonymize it. CCPA uses de-identification. And so our privacy automation solution allows you to automatically look at a data set, determine what are direct and indirect identifiers within that data set. It can automatically assess the risk of re-identification for that data set, in which case then you can start to take the proper steps to reduce the risk by applying privacy actions. And once you've applied those privacy actions, you can then also check the risk again before you publish it into a data science environment. It could be directly into a data lake, or it could be directly to the data scientists themselves. So I thought I'd walk through and show you an example of this data set that I have loaded up into our desktop app, which is great to demonstrate the various features of our software. So upon loading this data set, it comes up with a risk of re-identification or privacy risk of 100%, and that's because there are direct identifiers. So names and IDs will peg that number. There is no information loss yet because we haven't done anything to this data set. So let's do the first thing. Let's look to see if we've actually correctly identified each of these fields. So if we go into the advanced options pane, you see each of the fields, and then it tells you what type of attribute. Is it indirect? Is it direct? Or could be, well, here we say quasi, but it could also show sensitive or insensitive attributes as well. So the first thing we're going to do is to take out those direct identifiers. What's really interesting about this data set itself is that the risk of re-identification is still at 99%. And that means that the expected proportion of records in this data set, if you were to link it back to the original data set, could be correctly identified up to 99%. That's a pretty staggering number considering we took out the direct identifiers. So now let's go back in. And one of the features that we have in this model is that we can apply rules to each of those fields. So one of the problems that we see when people attempt to do anonymization or de-identification is that it goes too much or too far and there's not enough analytical value left. our software allows that control down to, allows the data scientists to control the fidelity of each of the fields so that they can still run the analysis that they would like to do on this specific data set. So here I've applied some rules. These are very simple rules. I'm going to redact the postal code by 3 digits. I'm going to bin the age by 5 years. And I'm going to apply some hierarchy levels to marital, education, and occupation. So if we go back and we hit our protect button and it applies that, we've now reduced the privacy risk to 33%. The information loss is bumped up to 13%. And so while that's helped, that certainly hasn't solved the problem. There's another thing here that I should point out, and it tells you, it's called the current K value. It tells you if we were to combine those fields, those quasi-identifiers, what is the smallest grouping that exists? So we call them equivalence classes. And so if you have gender, age, race, marital status, education, zip code, and occupation, even at this level of generalization, there's still one combination of all of those things where there's just one individual, which means that individual is still unique in this data set. And so what we can do now is do our automatic privacy applications by setting the level of protection to low, which means that I don't want any grouping to be less than 3. So there's got to be at least 3 individuals and any combination of quasi-identifiers. And so by doing that, the privacy risk is jumped way down to 5%, and the information loss has gone up to 24%. And that's based on the fact that we've had to remove a couple more zip code digits, and we've actually suppressed some rows. So suppression comes in when generalization can't actually bring everything in without seriously taking out, without generalizing a significant amount. So it's a balance between how much you generalize and whether or not you should take that individual out. So you could think of an outlier. So I was going to show one more example here. And in this case, I was thinking about, like, what if, as a data scientist, you're like, you know, race is really just not that important for the question that I'm trying to solve, so I'm just going to take that one out altogether. So I've applied full redaction to that variable. So how has this changed the risk of the data set? It's now gone down to 3%. And I've also managed to not do the suppression that I had before. So now I have more training examples in my data set. And you can see how you can play with those different fields to get the fidelity that you want. We can also, through this interface, set the maximum amount of generalization you want on any of the fields. It gives an extreme amount of control to the data scientist. And the other thing that I wanted to just highlight, we also have the ability to do tokenization on certain fields. So let's say you don't want to just get rid of the IDs, maybe you just want to provide tokens because you want to be able to add data later. Of course, you have to keep these tokens and IDs in a completely separate location from this actual data set. So this is great for structured data. Okay. So what about those other data types that I had talked about? So for transactional data, where you'll have temporal signals, how do you deal with that? Well, you can use something like a discrete cosine transform to approximate that temporal signal and apply a certain level of generalization. For some of the other things, like named entity recognition, in order to pick out those individuals in free-form text. For the images, you can do image captioning to sort of understand what the image is and what is in that image so you know what you need to protect. So that was all about specific data types that people have and have no issues like accessing them, moving them around. I want to talk about another type of data, and this is what I'm calling location-locked data. So this is data you can't move. Why can't you move it? Maybe it's because of divisional boundaries, department boundaries, organizational boundaries, or international boundaries. So imagine you're a global organization, you have multiple offices all over the world, you'd like to be able to access that data and run analytics, but you can't move it out of those locations. How would you be able to run your analysis? Our second solution is our CN Insight solution, which enables virtual data collaboration. It allows you to build models on data sets that cannot be relocated. We use cryptography, and the protocol is secure multiparty computation. All data is converted to secret shares and cannot be reverse engineered. And the accuracy of the resulting model is the same as if training on co-located in the clear data. So how does it work? Let's kind of walk through a simple scenario. Let's say you have 3 businesses and they have data and they all want to work together. Again, this could be divisional, departmental, or international. So the data can't be moved and it has to be kept secret. So the first thing we do is our software gets installed in each location, which will ingest the data, and then we'll use a splitting technique in order to create secret shares of the data. So when you create the same number of shares as you have collaborative parties. So if you have 3 parties, you have 3 shares. And then you establish a secure connection, like VPN or something like that, between each of the organizations, because the way secure multi-party computation works is through communication. And so as they walk through a machine learning algorithm, they will have to communicate for each computation that involves data split at each of the locations. At the end of the computation, what they end up with is the statistical or machine learning model that they wish to train, and then can be revealed to either all of the parties or a subset of the parties, depending on the agreement that the parties went into. So this is how you could actually operate on data, even if you couldn't move it and aren't allowed to expose it. So that's our privacy protection, or privacy preservation and analytics. There's virtual data collaboration, which enables organizations to access location-locked data, and privacy automation, which addresses privacy compliance for processing of customer data in analytics by providing a robust and scalable privacy solution. Thank you.